Hello and welcome to AP CSA Unit 3 Lesson 4 Array Algorithms. All right, today we're going to go over a little bit of Level 2 and we're going to actually look at an example that's not part of your Exploring Algorithms activity guide, but we'll get a feel for how we can traverse through some arrays and get information that we want out of them. And then we'll take a little bit of a look at level 3 as well. So first off, let's take a look at our main method. When we press run, we're going to be creating a couple of arrays. A string array called cities list, a integer array called hours worked list. So these two arrays sometimes are known as parallel data, where information at the same index matches together. So for Seoul, 1967 is the average annual hours worked by their residents. In Tel Aviv, it's 1,898 average annual hours worked. Istanbul, 1832. Los Angeles, 1779. And Boston, 1779 as well. So we're going to take those lists and we're going to pass them as arguments to this cities object class. And let's take a look at cities. So we see there are two instance variables. So these are the lists being passed in to the constructor and being stored as the instance variables of this object. Then we have a method called hasAtLeast, taking in an integer parameter, and cities with value taking in another integer parameter. So through your exploration and modifications through your activity guide, you're going to be dealing with those two methods. Today, I'm actually going to add another method, and I've actually already begun here. One method called getHoursByCity. So this is going to be built to find and return the hours worked for a given city. So if I knew a city in the list and I didn't know the hours worked that matches up with it, I can call that method and give it, say, Los Angeles, and it should return back to me the hours worked corresponding with Los Angeles. So we're going to build that up, and we're going to do so while also using this nice visual of both arrays. So you'll know I have both arrays set up here, one on top of the other. Remember, parallel data, this data in index 0 matches, in index 1 matches, and so on. I've kept a little counter here. We're going to be keeping track of the index we're currently dealing with at any given time, and this little box to show exactly, okay, we're looking at this value right now, we're looking at this value right now. So we can keep track of that and run the code conceptually as well. So let's quickly, I'm going to comment out code that you're going to need when you're doing your work. I just don't need it for this example. And let's take a look at our new method, getHoursByCity. And I'm going to capitalize that B for proper camel case. So the idea here is that whoever's using this method is going to provide a string called city. And what we're going to want to do is go through our city list, checking, hey, is this the city they're looking for? No. Is this the city they're looking for? No. And when we find the city they're looking for, matching it with its corresponding hours worked. So visually, we might think of this. Let's say I call that method, and we're going to traverse through this list. We're going to start at index 0, and we're going to go, okay, is that the city they were looking for, Los Angeles? No, it's not. And we'll increase the index in our traversal. And so then we'll look at the next item in our list, Tel Aviv. Is that Los Angeles? Is that what they were looking for? No. Okay. Then we're going to increase our index again, this time to 2. Take a look at our list. Is Istanbul what they were looking for? No. We'll increase our index again, Is Los Angeles what they were looking for? Yes, it is. And because it is, we're then going to look at that same index in the other list. And that's the value our method's going to want to return, 1,779. So that's our goal here. Traverse through the city name list, looking for and checking for what the user wants. When we found it, we're going to use the index that it's at in our other list to return that value. So let's go back to our code. So first, let's set up a traversal with a for loop. So we're going to type for int index start at 0. And remember, when we're traversing a list, we're going to start our index at 0, and we're going to look for the condition while index is less than the length of the list we're working with. And the name of the list we're working with is city names. So city names dot length. And then we're going to increment our counting variable index. All right, so we have our basic traversal here. This is going to run through all the indices in our city names list. So now we want to do is when we change that index every time, we want to look at that city name and determine, is that the one that the person calling this method is looking for? And we do that with a conditional statement, an if statement. So we want to check if the current item in the list is the thing they're looking for, and that thing they're looking for is the city parameter here. So to get the current item, city names is the name of our list, and we'll look at the index that's held by the index variable. So this again is going to give us each individual item in that list one at a time for every time we go through the for loop. So we want to check, is that item the one we're looking for, the city parameter here? And if it is, we want to take a look at the corresponding annual hours worked list at that same position. And in fact, that's what we're going to return for this method. You'll note this method returns an integer because this is an integer array. This single item out of this will be an integer. So that will return the corresponding hours worked, right? So let's go ahead and call this and see what we get. So we have a cities object that we have called lifestyles, and we're going to call our new method get hours by city. Get hours by city, and it requires us to give it a string. So let's use the example we saw visually, Los Angeles, and that should return us 1,779. And let's just system.out.println that result. It should give us back what we're looking for. Let's run. Oops, and you'll know it says we're missing a return statement on line 56. Let's take a look for our cities.java, line 56, right here. So it's pointing at the end of this method and it says we're missing a return statement, but you can see right here, we most certainly do have a return statement. So what the Java compiler is looking at is that return statement's inside a conditional, right? There is no guarantee that this is ever going to be true. Maybe instead of Los Angeles, maybe I put in Sunlantahunga, right? Or I put in any other city you can think. I put in London here, right? Then we know that this if statement will never be true, and so it will never run this line of code, in which case this method never returns an integer like it is supposed to. So what we have to do for that is make sure that we give a return statement when we don't have a result. So because we're returning an integer, we might return a default value of 0, let's say. Now note where I typed this return statement. I typed it outside of our traversal, outside of the for loop. Many people might think, oh, well, shouldn't you put it in the else statement? Because if you don't find it, if that's false, that's when else runs. But note that this if conditional statement runs every time through the for loop. So we're not going to want the else here because it would try returning 0 on possibly the very first time through the for loop. And we don't want to return something on every time through the for loop. The key thing to remember here is that the return keyword can only be used a single time. The second your program sees return and it gets a value it has to return back, it is going to exit out of the method and be done with it. So let's say this if statement's true on the first time through the for loop, well, it's going to return a value. The for loop is done. It will not continue, and the method will be done. It'll return back to where it came from and continue the code there. That's what return does. It returns to where the method was called. So that's why we're going to have it outside the for loop. So if the for loop runs and this if statement is never true, line 53 here never returns. And so the for loop will exit, continue down to line 57, and return this default 0. And so this return is if that city is not found. So let's double check to see if that will work. Get rid of this error. We'll keep Los Angeles from our visual setup here, where we saw it should return this 1,779. And then we'll try a city that's not in our list. So right here, you'll note that we're getting a 0. So something is a little off. I have a typo. So note, we actually found this city is not in our list because of my typo. And because of that, our for loop must have ran throughout the list. This if statement was always false. So it never got to run this return statement. And so the for loop ended, and we actually returned 0 here on line 57. Let's add a little comment here that this returns if the city is not found. And if we were doing something like returning a string, as you see in the method above, we could actually tell the user or that, hey, this thing wasn't found in your list, by the way. When we're returning an integer, a little bit different. We have to return back some sort of value that might signify that, hey, something's wrong here. Nobody works in this city. Doesn't quite make sense. So let's change that to a properly spelled Los Angeles. We know that's in our list ahead of time, and we should expect 1,779 to be returned. Let's run it one more time, and there is our result, 1,779. So let's go through that one more time. We have a traversal for loop with our control variable index starting at 0, from index less than the city names dot length, incrementing index every time. And we check in that list, city names, at that index, if it equals this parameter city that whoever's using this method has entered in. If that's true, we return its parallel data in the other list at the same index. If that never runs, that means our city was never equal to that item in the list. Then we are out of the for loop and we return this default value at the end. Visually, one more time, our loop starts at index 0, and this if statement's going to look at the first item and compare it to that parameter. So again, our parameter in this case was Los Angeles. So it says, nope, that's not true. Our for loop then increments our index variable. It then has another if statement checking, is Tel Aviv equal to that parameter of Los Angeles? No, it is not. So our for loop increments again. It checks if Istanbul is equal to that parameter of Los Angeles. No, it's not. We increment again. Is Los Angeles equal to that parameter? In this case, it was. So then it returns at the same index from the other list. Now, if that city wasn't there, our index would increment again. It would check the last item in our list. No, that's not the one we were looking for. It'll increment our index one final time. You'll note that that breaks our condition. Our index is now greater than the length, or not greater, but equal to, which means it's definitely not less than, as our condition states. So then our for loop exits, and we run this line of code in line 57. So I hope that helped a little bit understanding how we can design an algorithm for finding specific things in a list. So let's take a quick look at level 3. For my students, I'm going to ask on this choice level that you complete 2 of these. Why? Because I'm going to complete with you right now part D, art. We're going to determine if a 1D array of the year's specific artworks were created contains at least one value that is equal to a specific value. So very similar to what we just saw. Essentially, we're going to see a second example of this. So let's take a look. It says the art class has instance variables for 1D array of artwork titles and the years that they were created. So you know, similar setup. We have our arrays of information with parallel data. We create this art object called myArt. It takes those in as arguments to the parameterized constructor that then sets artworks and years, our instance variables, value. We then have a get artworks that returns the string array, get years that returns the integer array. We then have has year. That's not completed for us. Note, it does have the default return. So if we just called this right away, it doesn't matter what parameter we give it, you'll note the only code that runs in here is this return false. So this Boolean return will be false when we say artwork has at least one created in 2007. Right now it'll say false if I just run this. So let's check it. Yeah, it says false, but I want you to note that we clearly have a year 2007 in here for the artwork called Our House. So that should return true when we're done here. So note the instructions say it should return true if at least one value in the array is equal to the parameter years defined. It says traverse the years array to check the current value. Remember, when we check something, that's a conditional statement. That's our if statements to check, is this thing true? So let's make our traversal again. So for integer index, a lot of people shorten this to just I a lot of the time, but you really can call this whatever you please. And we always say that value less than our years list. Let's make sure it's the name of our list. Yeah, years. Its length, always less than that length. That way we go from 0 to one number under its length. Remember, the last index of a list is always one less than the length, which is why we do that. We increase that value every time through the loop. And now to check if the current value is equal to year defined. So similar to what we saw before. The current value, that's always the list we're working with at the index variable value. We check if that is equal to the parameter year to find. And then it says if it is, return true if the current value is equal to that. So we'll return the Boolean true. Now again, if that year didn't exist in the list, this conditional will always be false, and it will run through the entire for loop not finding anything, and then skip down to line 46 and return false at the end. That's why it says if no values in years is equal to year defined, return false. They already set that up for us. And again, might be a nice comment. Returns false if the year was not found. And again, that's because our for loop will have exhausted itself and skip down to the next line of runnable code. So let's check to see. We should get our house was made in 2007, so we should get this to say true when we run it this time. And there it is. It says artwork has at least one created in 2007, true. And let's just verify this with another year. Let's try 2008. We know that's going to pop up. There's 3 of them, so it should be true. And then we'll test it. Yep, there it is. We'll test it one more time. Oops, I should have changed the text in here to say 2008. Let's check 2010. We see knowing the data in our list ahead of time helps us debug this and make sure that it's giving us the results we want. And we know 2010 is not in here, so it should return false. Yes, it does. Wonderful. So this type of debugging where we already know all the information in our list is really helpful to know the result of what our method should be outputting. A lot of times when we're coding, though, you're not going to have that ability to know all of the data within the arrays you're looking at. However, dealing with smaller arrays or dealing with a test array when you're making code like this really helps debug and find problems and make sure that, a little sanity check that it is in fact working the way you've intended it to work. So again, if you're in my class, you're going to complete either A, B, or C on your own or with a neighbor. And don't forget to do a code review with your neighbors as well. Make sure you help each other out. And the check for understanding at the end of the lesson. So with that, I hope it helped. I'll see you next time.